Hey everybody, welcome back to the Algebra 2 series. This is our second part of function properties, and today we're going to look at average rate of change and also the difference quotient. So notice we have a function given, x squared, and we'd like to find the average rate of change between two different points, negative 1, f of negative 1, and 3f of 3. So to find that average rate of change, you can simply take this, and of course, we already know the answer to that second part. What does this computation represent? It's going to represent the slope of the segment or the line connecting these 2 points. So in this case, we're going to write this as average rate of change, or ARC. I tend to use ARC. And in this case, it's going to be f of 3 minus f of negative 1 over 3 minus negative 1. And again, what we're doing is finding the average change from the y values over the average change for the x values, which is going to be the same as calculating a slope. So get used to this subtraction in the top, subtraction in the bottom. In the case of f of 3, we do actually have to calculate f of 3, so we'll just do it right underneath here. F of 3, of course, is equal to 9, and f of negative 1 is equal to 1. So we'll need those two values. In the first case, then, you're going to get 9 minus f of negative 1 is 1, and then 3 minus a negative 1 is the same as adding 1 here. So we end up with 8 over 4, or 2. So that is telling us the slope of what we call the secant line. So the slope of the line containing those 2 points. Seems pretty simple. Well, the problem is once you get to that point where you understand it, we kind of mess you up a little bit more. And we put in something like this, f of x and x. And what? What is going on there? What happened to our nice friendly point, 3f of 3? Well, what we're doing is we're saying the one f of 1, this one right here, is tethered. So I'm going to write the word tethered here. I call this my tethered point. And the other point, x f of x, is not tethered. So I'll just let a little happy face represent him because he can be whatever he wants to be. So we're going to still write the same thing. Average rate of change is equal to f of x minus f of 1 over x minus 1. And notice, of course, that there's really no difference between this and the last problem, except that we don't have a number to put in for the first part. So f of x is simply given as this expression here. We're going to write that as x squared minus 3. Oh, gosh, let me redo that. There, that's pretty ugly. X squared minus 3x plus 3, and then minus f of 1. So once again, I'm going to write my f of 1 right here. 1 minus 3 plus 3 is 1. So f of 1 is 1, and I'm going to write that there, over x minus 1. Okay, so what I'm doing here is replacing my numerators as I did in the last problem. So this gives me x squared minus 3x plus 2 over x minus 1. Notice your numerator does factor to x minus 2 times x minus 1 over x minus 1 and answer x minus 2. So what have we just found? Well, we found a very strange thing. We found an answer that is x minus 2. This is the average rate of change between the 2 points, a fixed point, 1f of 1, and a non-fixed point, x f of x, on this particular function right here. So what we found is a variable or an expression that represents the slope. And we count that as m typically, but the slope is going to be x minus 2, depending on what the x value is. So that's kind of a slick little thing. Uh, Let's take a look at this final question. It says, use your result from above to write the equation of the line through 1f of 1 and 5f of 5. Aha! Guess who that is? That's our happy face guy. That's x f of x, because in the previous problem, they told us what 1f of 1 was and what the function was. So this 5f of 5 now, we are fixing our um, our point, and we don't have to use anything except for this guy right here, that x minus 2. So notice that in this particular case, the x minus 2, or the 5, is representing x, and so x minus 2 is going to equal 3. And the number 3 is going to be the slope. So let's take a look at that. We'd like to answer in this form for a line. Well, we know the equation of a line is best found as y minus y1 is equal to m times x minus x1, point slope form. And we need a point and we need a slope. Well, we've got our slope right over here. What we need is a point. Let's go back to the top here and see that we actually have a point. It's right here. It's the point 1 comma f of 1, and we calculated f of 1 right there. So we already did that work, and all we have to do is plug it in. It's the point 1, 1. So we'll put that in right over here. We know that xy is going to be the 0.11, and we know the slope is going to be 3 from our computations on the right side there. So y minus 1 is equal to 3 times x minus 1, or y minus 1 equals 3x minus 3. So let's finish this out. Negative 3x plus y equals negative 2, and if you wanted to multiply that all out, you get 3x minus y equals 2 if you want it to be really pretty. I like it to be really pretty. Multiply through by negative 1 there. All right, let's move on. So we've already seen an example now where one of the points is fixed and the other point is unfixed. And here's another example written a little bit differently. So here we've got a negative 1 f of negative. Let me back that up just a tad here. We're talking about negative 1 f of negative 1, and we're talking about p f of p in this problem. And here is our function, which is rational, and that is going to be a little bit nasty. So let's give our shout out to the average rate of change formula, because that at least keeps us going here. F of p minus f of negative 1 over p minus negative 1. Again, I'm just doing kind of a slope calculation with these 2 points. And in this case now, f of p is simply putting a p into the function over here. Ooh, boy, that's going to be fun. So that's going to make an interesting fraction. The denominator does not have f of anything. It just has p minus negative 1 or p plus 1. So I'll write that in right there. So let's calculate a couple of these things over here. So we like to do this on the side. F of p is going to equal just p plus 1 over p. So I'm good with that one. F of negative 1 is going to be negative 1 plus 1 over negative 1. Wait a minute, that's 0. Okay, that's cool. I like it. All right, so I've got a p plus 1 over p minus 0. And that gives me a complex fraction p plus 1 over p all over p plus 1. And we'll see then if we multiply the top and bottom by p. I mean, you can almost do this in your head, but whatever. That would give you a p plus 1 over p times p plus 1, which cancels, leaving us 1 over p. All right, I'm going to put that in a little green cloud there. So that's the average rate of change, or the slope, between the point pf of p and negative 1 f of negative 1 for that function. And of course, obviously, we could not have an x value or a p value of 0 because we can't plug 0 in. Could the answer that you found in exercise 3 above help you to find the slope of the secant line right here? And the answer is no. And that's because neither of these points matches our tethered point. We would need negative 1 f of negative 1 must be used. So I'm just going to write must be used because we need to have that tethered point. You can't do this formula here. You can't use that answer for numbers like 2 and 6. All right. So that takes care of the average rate of change problems. And finally, we've got this one, which is the difference quotient. And this is the standard difference quotient in mathematics. And in this case, instead of one untethered point, they allow us to have 2 untethered points. So x is untethered. It can be anywhere. And the other point over here can be anywhere as well. And it is h units away. So the x value would be x plus h. That's how we would determine this x value, because it's h units away. So this would be x comma f of x. That's not a hard ordered pair to find. And the other point would be x plus h comma f of x plus h. That one is a little bit trickier. So doing the average rate of change here, I'm just going to make a little mess. Average rate of change would be f of x plus h minus f of x. I'm subtracting these two guys. And then divide that by x plus h minus the other term, the x. And notice that in the denominator, your x's drop out. And so you end up with just the h value loaded here. Okay, so that's what we're going to use in our next set of computations. And I'll start posting those as we move along through this. But that's the extension of average rate of change.